All right, you magnificent bastards. Strap yourselves in for a cosmic-sized deep dive into the future of space exploration.
We're going to dissect humanity's obsession with space.
We've got a mountain of intel here. Wikipedia, scientific journals, all that brainy crap.
And we're going to break it down, no bullshit.
We're going to give you the unvarnished truth.
About what it really takes to conquer the final frontier.
So why the hell are we even bothering with space?
Isn't it enough of a shit show down here on Earth?
I mean, we've got climate change.
Pandemics?
And politicians who can't seem to agree on whether the sky is blue.
Why the hell are we so fixated on what's happening millions of miles away?
Oh.
It's not just about escaping this planet when things go completely sideways, though that's certainly a part of it.
So we're basically talking about a cosmic fire escape for when we inevitably screw things up down here.
Precisely, but it's not just about survival.
Space is also a treasure trove of resources.
Minerals, energy sources.
A goddamn gold mine floating out there just waiting to be tapped.
Of course, there's also the scientific aspect.
All right, the whole aliens thing.
The sheer fuck yeah factor of discovery.
I mean, who hasn't looked up at the stars and wondered if we're alone in this goddamn universe?
Exactly, that primal drive to explore, to push the boundaries of what we know.
Okay, I get the romantic side of it.
It's deeply ingrained in our DNA.
But let's cut the crap for a second and get down to the nitty-gritty.
And space represents the ultimate unknown, a vast and mysterious frontier that beckons us to venture beyond our comfort zone.
How the hell are we going to actually do this?
You're right.
I mean, space is a pretty hostile environment for us fleshy meatbags.
The human body is a delicate instrument, and space is not exactly a welcoming place.
Yeah, I remember that article you shared about biosphere, too.
We're talking about bone-crushing gravity radiation that can fry your brain and the psychological toll of isolation and confinement.
That experiment where they stuck a bunch of people on a giant terrarium to simulate a self-sustaining space colony?
Precisely, Biosphere 2 was a cautionary tale.
They almost killed each other.
It highlighted the psychological and social challenges of long-duration space travel.
Okay, so we're getting better at prepping our meat sacks for space.
But we're learning from those mistakes.
Mm-hmm.
We're developing new technologies and training protocols to mitigate the risks and ensure the well-being of our astronauts.
But what about the tech?
We've come a long way since the Apollo era.
I mean, are we still relying on those clunky-ass rockets we've been using since the 60s?
We're seeing incredible advancements in propulsion systems, spacecraft design, and life support technologies.
Interstellar travel.
But we still have a long way to go, especially if we're talking about interstellar travel.
That's the whole traveling to other star systems thing, right?
It's mind-bogglingly vast.
Isn't that basically a pipe dream?
Even at the speed of light, it would take years to reach the nearest star system.
I mean, space is freaking huge.
And with our current technology, we're talking about travel times that span generations.
Generations? Shit, that means we'd need a spaceship the size of a goddamn cruise liner with enough supplies and entertainment to keep people occupied for decades.
That's one approach to this so-called generation ship concept, but there are other possibilities.
Warp drive. Hold up, isn't that some Star Trek bullshit?
Scientists are exploring radical propulsion systems like nuclear fusion engines and even theoretical concepts like the Alcubierre drive, which could potentially warp space-time to allow for faster-than-light travel.
Okay, I'm officially lost.
It's definitely still in the realm of science fiction, but the theoretical physics behind it is intriguing.
Let's stick with something a little closer to reality.
The Alcubierre drive proposes distorting space-time to create a warp bubble that could, in theory, allow a spacecraft to travel faster than light without violating the laws of physics.
What about robots?
Robotic exploration is a crucial aspect of space exploration.
I mean, they don't need to breathe, they don't get space sickness, and they don't bitch about the food.
We've sent probes to every planet in our solar system and beyond, and we're seeing incredible advancements in AI and autonomous systems.
Aren't they the perfect astronauts?
But robots can't replicate human ingenuity and adaptability. There are still tasks that require the human touch, so to speak.
So it's a team effort.
It's more nuanced than that, but essentially, yes.
Robots do the grunt work, and humans come in to do the fancy science stuff.
We need both human and robotic exploration to unlock the secrets of the cosmos.
Okay, so we've got the human factor, the robot factor, and the need for some seriously kick-ass propulsion systems if we're ever going to get beyond our own cosmic backyard.
That's where the private sector comes in.
But let's talk about the elephant in the room.
Companies like SpaceX Blue Origin and Virgin Galactic are investing billions in space technology, driving down the cost of space travel and opening up new possibilities for commercial ventures, scientific research, and even space tourism.
Who the hell's going to pay for all this?
Right, the whole space tourism thing.
Isn't that just a rich person's playground? I mean, who the hell can afford a joyride to space?
Space tourism is certainly a luxury at the moment, but as the technology matures and competition increases, we can expect prices to come down.
Okay, I'm starting to see the appeal.
Imagine a world where a trip to orbit is as affordable as a cruise to the Bahamas.
Space cocktails, zero gravity sex, sign me up.
But let's not get ahead of ourselves.
But let's not get ahead of ourselves. We still need to figure out how to keep our astronauts from turning into space dust and going batshit crazy from isolation.
Absolutely. The human factor is paramount. We need to develop technologies and countermeasures to mitigate the physiological and psychological challenges of long-duration space travel.
Speaking of challenges, let's talk about the big one.
Mars is the most Earth-like planet in our solar system.
Mars.
It has a similar day-length evidence of past water and the potential for resources that could support a human colony.
Okay, so it's not a barren wasteland. But what about the distance?
That's why we need to develop robust life support systems, redundancy in our spacecraft, and advanced medical technologies to handle any emergencies that might arise.
It takes months to get there, even with our fastest spacecraft.
There are various theories on how to terraform Mars, but it would be a monumental undertaking requiring centuries of effort and untold resources.
And what if something goes wrong?
We're still in the early stages of understanding the Martian environment and developing the technologies necessary for such a massive planetary engineering project.
You're not exactly calling AAA for a tow truck on Mars.
There are a few candidates.
But let's not forget the whole terraforming thing.
Europa, a moon of Jupiter, has a subsurface ocean that might harbor life.
Turning a cold, dusty planet into a habitable environment sounds like a pretty tall order.
Titan, a moon of Saturn, has a thick atmosphere and methane lakes, which could be potential sources of fuel.
Are we talking about nuking the poles or something?
And then there are the asteroid belts, rich in minerals and resources that could be mined for future spacefaring endeavors.
All right, so Mars is a long shot, but at least it's on the table. What about other potential destinations?
That's true, but the landscape is changing.
Are there any other planets or moons in our solar system that might be worth checking out?
With the rise of private space companies and the increasing affordability of space technologies, we're seeing a democratization of space exploration.
So we've got a whole cosmic buffet to choose from.
It's no longer just the domain of governments and superpowers.
But let's be honest, right now, it's still a very exclusive club. You practically need to be a billionaire to even sniff a chance at going to space.
It's certainly possible.
So you're saying that one day, even schmucks like me might be able to afford a trip to space.
The future of space exploration is full of potential, both for scientific discovery and for expanding human presence beyond our planet.
Okay, I'm starting to feel a little less cynical about all this space stuff. Maybe it's not just a billionaire's vanity project after all.
It's about much more than that.
It's about pushing the boundaries of human knowledge, exploring the unknown, and ensuring the long-term survival of our species.
Welcome back to the Deep Dive. Last time we talked about humanity's grand ambitions and existential anxieties about space.
Now let's get down to the nuts and bolts, the tech that might actually get us off this rock.
We talked about the need for some seriously badass propulsion systems if we're ever going to reach another star system.
What are we looking at? And how close are we to ditching those chemical rockets for something a little more Star Wars-y?
Chemical rockets, the kind SpaceX uses, are great for getting us off Earth and into orbit.
So what are we talking about? Warp drives?
They're powerful, but they guzzle fuel like a frat boy at a keg party for interstellar travel. We're going to need something entirely different.
Antimatter engines. Beam me up, Scotty, and all that.
Not quite yet. Those concepts are fascinating from a theoretical standpoint, but they're still science fiction.
Yeah, that one was pretty dense, basically. You smash atoms together.
Remember that article you sent about nuclear fusion? That's a more realistic near-future option.
To release a shit ton of energy, right?
Exactly. Fusion's energy output blows chemical reactions out of the water.
So instead of tens of thousands of years to reach the nearest star system.
A fusion-powered spacecraft could theoretically reach a significant fraction of the speed of light.
We're talking maybe a few decades.
Potentially, yes, but fusion propulsion is still in its infancy.
That's still a long-ass time, but it's better than spending your entire life on a spaceship.
We haven't even achieved sustained fusion reactions here on Earth, let alone built a spacecraft powered by it.
Right, so it's a long shot, but it's on the table.
Yeah.
What about those other ideas like ion propulsion and solar sails?
Ion propulsion uses electricity to accelerate ions, creating a very faint but continuous thrust.
Are those viable for interstellar travel?
It's highly efficient, but it's like watching paint dry. It takes a long time to build up speed.
So ion propulsion is the tortoise, and solar sails are.
Solar sails harness the momentum of photons from the sun to propel a spacecraft.
An even slower tortoise.
Even slower, but they don't need any onboard fuel. A good analogy, both have their uses.
Okay, well, let's say we crack the propulsion problem and have a spacecraft that can get us to another star system in a reasonable time frame.
Particularly within our solar system for true interstellar travel, though we'll need something more radical.
What happens when we get there? Do we just plant a flag and take a selfie and call it a day?
That's where things get really interesting. The goal isn't just to visit another star system.
So we're talking about colonizing other planets, building cities on alien worlds like in those sci-fi movies.
But to explore it, study it, and maybe even establish a permanent human presence there.
Terraforming. Sounds like something out of a video game.
That's the long-term vision, but it's a daunting task. We'll need to find planets that are habitable or at least capable of being terraformed to support human life.
You mean like turning a barren wasteland into a lush paradise?
Exactly. It involves altering a planet's atmosphere, temperature, and surface to make it more Earth-like.
And let's not forget about the alien life thing. What if we stumble upon a planet that's already inhabited?
It wouldn't happen overnight, but it's a possibility if we're serious about becoming a multiplanetary species.
Yeah, I'm guessing it wouldn't be all peace, love, and intergalactic kumbaya.
That's the million-dollar question. First, contact with an alien civilization would be one of the most significant events in human history.
More like, take me to your leader, and then, boom, alien invasion.
Forcing us to reconsider our place in the universe and grapple with some profound ethical questions.
All right, let's bring it back down to Earth for a second. We've been talking about all this futuristic stuff.
Hopefully we can avoid any intergalactic conflicts, but the possibility of encountering other intelligent life is both exciting and terrifying.
But what's happening right now?
Plenty happening right here, right now. One exciting development is the rise of reusable rockets.
What are the coolest advancements in space exploration that are going down in our own backyard?
SpaceX has been leading the charge with their Falcon 9 and Falcon Heavy rockets, which can land back on Earth after launching a payload into space.
So no more tossing those expensive rockets into the ocean after one use. That sounds like a good deal.
It's a game changer for the economics of space travel. Reusable rockets drastically reduce the cost of launching payloads into orbit.
Speaking of space tourism, that's becoming a thing, right? I've heard about Richard Branson and Jeff Bezos taking joyrides into space.
Opening up possibilities for commercial space ventures, scientific research, and even space tourism.
So maybe one day, instead of taking a cruise to the Bahamas, we'll be taking a rocket to the moon for vacation.
Yes, space tourism is gaining momentum. Virgin Galactic and Blue Origin offer suborbital flights that give passengers a brief but unforgettable taste of space.
Inflatable space hotels, sign me up.
They're still expensive, but as the technology matures and competition heats up, we can expect prices to come down. Companies like Bigelow Aerospace are developing inflatable space habitats that could be used for hotels, research stations, or even permanent settlements on the moon or Mars.
But let's not get ahead of ourselves. We've got a lot to figure out before we're setting up shop on other planets.
Absolutely. But the progress we're making is remarkable. The investment in space exploration, both from governments and the private sector, is unprecedented.
It feels like we're on the verge of a new era of space exploration, driven by innovation, commercialization, and a renewed sense of wonder.
I agree. The discoveries we make in the coming decades could fundamentally change our understanding of the universe and our place within it.
Okay, so we've talked about the mind-blowing potential of interstellar travel, the rise of reusable rockets and space tourism, and the possibility of terraforming other planets.
Right. We talked about some of the physiological challenges in the last episode, like bone density loss and radiation exposure.
Let's get down to what it's actually like to live and work in space.
Yeah.
Yeah, that was some scary shit. But I want to dig deeper into the psychological side of space travel.
It's definitely not for the faint of heart.
It's got to be pretty fucked up to be living in a metal can, hurtling through the void millions of miles from home.
Isolation, confinement, and the constant awareness of the risks involved can take a toll on even the most well-adjusted astronauts.
So what are the biggest psychological challenges astronauts face, and how the hell do they cope?
One of the most significant challenges is the lack of privacy. You're living and working in close quarters with a small group of people 24/7.
Yeah, I can imagine that getting pretty claustrophobic after a while. It's like being stuck on a never-ending family road trip with your most annoying relatives.
There's no escape from the constant noise, the lack of personal space, and the inevitable interpersonal conflicts.
Except the car is a spaceship, and you're all hurtling through space at thousands of miles per hour.
Not ideal, to say the least, and the stress of the mission, the constant demands of work, and the lack of contact with loved ones can exacerbate these pressures.
So how do astronauts stay sane in such an extreme environment? Are they all Zen masters who can meditate their way through anything?
Astronauts undergo rigorous psychological screening and training before they're ever selected for a mission.
So it's all about mental toughness.
Yeah.
Got to be able to keep your cool when everything around you is literally trying to kill you.
They learn coping mechanisms for stress conflict resolution and maintaining a positive attitude in the face of adversity.
Makes sense. You're all in it together, so you better learn to get along.
That's a big part of it, but it's also about teamwork, communication, and a shared sense of purpose.
But I'm curious about the long-term effects of space travel on the psyche. Do astronauts come back to Earth fundamentally changed?
That's a question still being studied. Some astronauts report a profound shift in perspective after seeing Earth from space.
The overview effect, right? Like seeing the Earth as this tiny, vulnerable ball floating in the vastness of space. I can see how that would mess with your head in a good way.
They talk about a sense of awe and wonder, a newfound appreciation for the fragility of our planet, and a deeper understanding of our interconnectedness as a species.
But I'm guessing it's not all rainbows and unicorns. There must be some downsides to spending extended periods in space.
Exactly. It can be a transformative experience both psychologically and spiritually.
You mentioned I sent you that article about space food.
Of course, some astronauts experience post-flight depression, anxiety, and difficulty readjusting to life back on Earth.
What the hell do astronauts eat in space? I'm guessing it's not Michelin-starred dining up there?
You're right, space food has come a long way since the early days of squeeze tubes and powdered drinks.
So what's on the menu these days? Dehydrated space lasagna. Freeze-dried space ice cream.
But it's still a far cry from a gourmet meal.
So it's not all bad, but I bet it gets pretty boring after a while.
There's a surprising variety of options, actually. Astronauts can choose from pre-packaged meals heated in a special oven, thermostabilized pouches eaten cold, and even some fresh fruits and vegetables flown up from Earth. It definitely lacks the sensory variety and social experience of eating a meal on Earth. There are also unique challenges to eating in zero gravity.
Yeah, I'd hate to have a stray Cheeto floating around in the spaceship's control panel.
Food floats around, and crumbs can become a hazard if they get into sensitive equipment.
All right, we've talked about the food, the psychological challenges, and the mind-blowing possibilities of space travel.
So that's why astronauts have to be very careful about how they eat and clean up after themselves.
But there's one question that's been bugging me since we started this whole space exploration thing.
What's that?
What about sex in space? I mean, it's got to be happening, right?
That's a question that sparked a lot of speculation and, shall we say, creative writing.
Humans are humans whether they're on Earth or orbiting Jupiter. But no one's officially admitting to it.
Officially, no, but it's certainly been discussed among astronauts and scientists. Remember that research paper you shared about the physiological effects of microgravity?
Yeah, the one that talked about bone density loss and muscle atrophy. What does that have to do with, oh, right, everything works differently in space?
Exactly. There are logistical challenges to intimacy in zero gravity.
So no space babies anytime soon.
Not to mention questions about the effects of radiation on reproductive health. It's not exactly a romantic setting.
All right, folks, that's it for part 2 of our deep dive into the future of space exploration. We've covered a lot of ground.
We may have more concrete answers as longer duration space missions become more common.
From the nuts and bolts of interstellar travel to the down-to-earth realities of eating, sleeping, and, well, maybe even getting busy in space.
We've explored the psychological and ethical challenges of venturing beyond our planet and considered what the future holds for humanity among the stars.
Welcome back, you magnificent space nerds. It's the final frontier of our deep dive into space exploration. We've talked tech, we've talked astronaut poop, now it's time for the big picture shit.
Indeed, having explored the practicalities and, shall we say, intimate details of space travel, we now turn our gaze to the philosophical implications of humanity spreading its wings into the cosmos.
All right, less fancy talk, more mind-blowing shit. Hit me with the cosmic existentialism. Why does all this space exploration crap really matter in the grand scheme of things?
It's about more than just planting flags and mining asteroids. It's about expanding human knowledge, understanding our place in the universe. You know how you were fascinated by that Carl Sagan quote in the materials you sent about the pale blue dot?
So we're just a bunch of cosmically insignificant specks in a giant cold void. That's pretty bleak, man.
It made me think about the vastness of the universe and how our existence on this tiny planet is just a blip in cosmic time. Not necessarily.
Okay, I see your point, but let's get real.
It's about perspective. Recognizing our smallness doesn't diminish our significance. It highlights the preciousness of life and the incredible achievement of our species in even contemplating such questions. Right now, space exploration is a game for governments and billionaires. How does any of this philosophical stuff affect the average Joe Schmo stuck on Earth?
Right, that fuck yeah, we're going to Mars kind of vibe.
It's about inspiration, aspiration, pushing the limits of what's possible. Remember all those technologies you use every day. GPS, satellite communication, even medical advancements.
But let's not forget the dark side. What about the potential for conflict? Weaponizing space, fighting over resources, the whole space war scenario.
Many of them stemmed from space exploration. Beyond that, it's about expanding our horizons, literally and figuratively. Knowing there's more out there that we're not confined to this one planet can spark curiosity and a sense of wonder. It can remind us that there's more to life than just paying bills and watching Netflix. It's a valid concern. As we venture further out, the stakes get higher. The Outer Space Treaty, signed back in 1967, prohibits weapons of mass destruction in space, but that doesn't cover everything.
You know, like that article you sent about the militarization of space.
The potential for militarization is there, and the competition for resources, whether it's helium-3 on the moon or rare earth minerals and asteroids, could easily escalate into conflict.
So we're potentially setting ourselves up for a cosmic version of the Wild West. Space cowboys with laser pistols duking it out over asteroid claims.
Hopefully we can learn from our past mistakes and avoid repeating them on a cosmic scale. International cooperation and a commitment to peaceful exploration are essential if we're going to build a sustainable future in space.
Yeah, those are some heavy questions. I'm guessing there's no easy answer.
Yeah, fingers crossed on that one. But let's shift gears for a minute. We've talked a lot about the practical challenges of space exploration, but what about the ethical ones? Are we just going to waltz into other solar systems and claim everything we find?
That's where things get really complex. We need to carefully consider the potential impact of our actions on other celestial bodies. Do we have the right to terraform another planet, even if it means altering its natural environment?
What if we encounter extraterrestrial life? Do we have the right to interfere with their evolution or claim their resources? There isn't. It's a conversation that needs to happen on a global scale, involving scientists, ethicists, philosophers, and policymakers. We need to develop a set of guiding principles for space exploration that prioritize sustainability, respect for other life forms, and the long-term well-being of humanity as a whole. Sounds like a tall order, but it's crucial if we're going to do this whole space thing, right?
So to wrap things up, let's gaze into our cosmic crystal ball. What do you think the future holds for humanity in space? Are we destined to become a multiplanetary species, or are we just going to fuck up this planet and then fade into oblivion?
The future is unwritten. It depends on the choices we make today. If we prioritize cooperation, sustainability, and the pursuit of knowledge, we have the potential to achieve incredible things. We could establish thriving colonies on other planets, unlock the secrets of the universe, and perhaps even encounter other intelligent lives. That's a future worth striving for. But if we let greed, short-sightedness, and our own self-destructive tendencies win out well, then it's probably game over for humanity.
The stakes are high. The choices are ours. Well said. So there you have it, folks. The good, the bad, and the existentially terrifying possibilities of space exploration. It's a wild ride full of mind-blowing challenges and even more mind-blowing potential rewards.
Remember, space isn't just a bunch of twinkling lights. It's a vast and mysterious universe beckoning us to explore its wonders and unravel its secrets. And who knows, maybe one day we'll be sipping space cocktails on Mars, gazing at the Earth rise, and pondering the infinite possibilities that lie ahead. Cheers to the future, you magnificent bastards!